Hello, and welcome to a tutorial to perform a configuration on a T-Wave T8 device. This tutorial shows how to set up an air extractor with two components, a motor and a fan. The extractor will operate at a fixed speed, so a tachometer will not be used. A piezoelectric accelerometer sensor will be utilized, taking measurements at two different points. Additionally, it will be explained how to define processing modes and parameters. Machine states and measurement storage strategies will also be configured. For this machine, an accelerometer will be used as the sensor. The first 5 boxes are intended to fill in information about the sensor, such as its name, a brief description, manufacturer, model, and serial number. In the signal section, specify the input unit, which in this case is acceleration in units of g. The sensor type is dynamic, and it is necessary to specify the sensitivity and offset. A frequency range can also be specified. In the limit section, it is recommended to select the checkbox Check AC/bias so the system verifies the maximum amplitude peak as well as the minimum and maximum bias voltage. If these values fall outside the range, the system will issue an error alert. Click Accept, and the accelerometer sensor will now be configured. In the section Inputs/Outputs, the T8 device inputs must be specified, as many as points you want to measure in the machine. In this example, 2 inputs will be configured, corresponding to the 2 measurement points. By clicking on one of the inputs, you can access its configuration. Here you must select the type of input, dynamic in the case of accelerometers. A DC coupling box is available to choose whether to include or exclude the continuous component of the signal. In the case of accelerometers, the box is left unchecked. In the sensor field, the sensors defined in the previous section are shown. In the channel gain field, the gain can be configured, which in turn modifies the input range. It is important to ensure that the input range is larger than the sensor's output range to avoid signal saturation and consequent data loss. For IEP accelerometers, check the corresponding box to activate the required current source. Simulation files can also be selected. This will be explained in more detail in another video. The second input is configured in the same way. The section's bearings, fault frequencies, Modbus, OPC will be covered in another video. In the section Techniques, different analysis techniques can be defined. In this case, only vibration analysis is used. This serves solely as an informational label. In the section Units, the properties and units available in the system are displayed and can be linked to the sensors, such as displacement, velocity, and time. The T8 comes with a factory predefined list, which cannot be modified, but new ones can be added according to the user's preferences. A photo or diagram of each machine can be associated in the Images section. To do so, a file from the computer must be selected. From here, the configuration of the machine itself will be carried out. To create a new machine, select the New button. In Tag, enter the machine's identifier. It is important to keep the Enabled box checked. Otherwise, the machine will be completely ignored and no measurements will be taken on it. Various machine characteristics can be specified, such as the name, a brief description, manufacturer, model, serial number, whether it has a rigid or flexible support, its nominal power, and the image previously uploaded to the system. This information is purely descriptive. In the monitoring section, it is necessary to check the Enabled box to allow monitoring and storage of measurements. When unchecked, previously recorded data can be accessed, but real-time measurements cannot be displayed. The Period field sets the refreshing rate or monitoring period for the measurements of the machine in seconds. For example, if the number 2 is selected, the interface will display real-time updates, such as parameters, waveforms, and spectra, refreshing in their respective widgets every 2 seconds. The monitoring period is independent of the sampling frequency. The delay at startup defines a delay time the T-Wave T8 unit will await for before starting the monitoring of the machine after a new configuration has been applied. This delay allows accelerometers to stabilize by waiting for its settling time to elapse. In the speed section, the machine's speed is defined. In this example, the air extractor has a fixed speed, so no tachometer is used. Instead, the speed is entered in hertz or revolutions per minute. In the configuration panel, next to the machine name, if you click on the gray circle to the left of the name, a hierarchical tree will expand showing the different objects that make up the machine. The first of these is alarms, where the machine's alarms can be defined, which will be covered in another video. Also, the components that make up the machine can be defined. In this case, two components are defined, a motor and a fan. Now, the measurement points of the machine will be defined. Select New to create a new point, choosing the type of point, in this case dynamic since an accelerometer is used. A label and name are assigned to the point, along with a description. This first point corresponds to the vertical orientation accelerometer of the motor. The enabled box must be checked for the point to be considered. The analysis technique to be used can also be selected, as well as the component to which the point belongs. If phase measurements are being carried out, the angle at which the sensor is placed must be selected correctly. An angle of 0 degrees corresponds to a vertical upper position. The angle direction can be selected as clockwise, R, or counterclockwise, L. The system does not allow two points associated with the same component to have identical or parallel angular positions. In the spin direction field, the direction of rotation of the axis, where the point is located, is specified. Angle references are typically set by looking from the driver's side of the machine to the driven part. It is also useful to place the point label on the mimic, which represents the location of the sensor on the machine. To avoid showing the point's label on the mimic, select the Hide Labels checkbox. In the Signal section, the input associated with the measurement point is selected. In Speed Factor, the factor used to calculate the speed associated with the point and its measurements is specified. In the hierarchical tree, by clicking on the small gray circle to the left of the point, the processing modes are displayed. To create a new one, select New and choose one of the processing modes. There are several options: waveform only, spectrum and waveform, demodulation, long waveform, order tracking, full spectrum. The tag, name, and description of the mode are specified. In the spectrum section, select the maximum and minimum frequencies. Also specify the number of resolution lines and the number of averages used to calculate the spectrum. In overlap, define the overlap value in percent that the processing mode will use for averaging the measurements. Keep in mind that modifying the values of lines and averages will also affect the resolution values, sampling frequency, duration of the waveform in seconds required to calculate the spectrum, and buffer size. It is also possible to select the type of window applied to the measurements. It is important to choose the correct spectrum property. In AC detector, you can select the detector applied to the amplitude of the spectrum. Typically, for measurements with accelerometers, RMS is selected. It is important to enable the Keep Data checkbox. If not, the spectrum data will not be kept and will not be able to be stored. In the Waveform section, you can specify the number of points that the waveform will have when displayed on the dashboard. This value also modifies the duration of the waveform and the buffer size. Remember to enable the Keep Data checkbox in order to allow storing waveform data. In the Filter section, if the enabled box is selected, a filter will be applied to the signal, affecting both the waveform and the spectrum. The type and characteristics of the filter can be specified. Now, in the hierarchical tree, By clicking on the gray circle to the left of the processing mode name, the parameters calculated in that mode will be displayed. Select New to create a new parameter and specify its tag, name, and description. The important part here is to select the type of parameter to be calculated. When the options list is expanded, the different types are shown among all. We start by selecting a spectrum-based root mean square. The first parameter defined in the first processing mode is the main parameter, marked with an asterisk, and it appears in the Mimic widget. Now we're going to create another processing mode, one similar to the previous one but for high frequency. For this processing mode, a peak-to-peak parameter is created. At this point, we have fully configured a measurement point of the machine, the two associated processing modes, and the parameters calculated in each of them. To add a new measurement point, simply click the Copy button to duplicate the first point, then change its name and click OK. This copies the configurations, processing modes, and calculated parameters for that point. We want this second point to belong to the fan in a horizontal position, so the only things to change compared to the first point are the label, name, description, the component, and the point's angular position. The label for this second point should also be placed on the Mimic if desired. As the input signal, when copying the point, the next available input is automatically assigned to the new point. By expanding the levels in the hierarchical tree, we can view the current configuration and components of the machine. Remember to click the Apply button to save and apply the configuration. Now let's go to the dashboard interface, where different values will be displayed. The dashboard displays the data on different windows called widgets. The button edit layout of the toolbar will show the desktop in edit mode, allowing the user to delete it, change its name, or change the configuration of the widget's layout. You can split the widget vertically or horizontally in two equal parts and also merge two widgets into one. The size of each widget can be changed by using the vertical and horizontal division lines. Once the layout has been defined, the user can assign a particular type of widget to the different windows of the desktop layout. Clicking on an empty one, a window will appear, showing the different type of widgets available. On this desktop, we will display a mimic of the machine, a parameter matrix, and some online values. You can choose which parameter values to display and select different layout types for them. To add a new desktop, click on the Add Desktop button, assign a name, and click Accept. Now, we will display a waveform and a spectrum widget. The Play/Pause button will make the values of the waveform and spectrum to be updated automatically with the latest measurements. In conclusion, in this first tutorial, we have seen how to configure a fixed speed machine with two measurement points on two different components, with two processing modes for each point and 4 parameters in total. Additionally, we demonstrated how to create a simple dashboard with the machine Mimic, a parameter matrix, and online values on one desktop and waveforms and spectrums on a second one. In the next video, we will show how to perform a more advanced configuration, adding states to the machine, storage strategies, and alarms. This will allow us to display trends on the dashboard, as well as view timelines in the parameter matrix widgets, spectrums, and waveforms.